Okay, this is Geometry Lesson 8.4. We're doing rhombuses, rectangles, and squares. So if you missed anything or if you missed class, you'll be able to fill in your notes. Our learning target is we're going to just learn the properties of rhombuses, rectangles, and squares. And again, we've already done the cheat sheet, so we've talked about it a little bit. Now I'm just going to go through what we did talk about. Okay, a rhombus corollary. A quadrilateral is a rhombus if and only if it has 4 congruent sides. So ABCD here, our picture, is a rhombus only if the top is the same as the bottom and the left is the same as the right. Okay, a rectangle corollary. A quadrilateral, again 4-sided figure, is a rectangle if and only if it has 4 right angles. So for it to be a rectangle, it must have 4 90-degree angles. So in this case, A, B, C, and D must all equal 90 degrees. And again, they're going to use the same symbols that we've been using. The little square means 90 degrees. Okay, let's make sure we're focusing. Okay, we're going to move it up. The square corollary. A quadrilateral is a square if and only if it is both a rhombus and a rectangle. Remember, we made that diagram that said a square has all of the properties of a parallelogram, it has all of the properties of a rhombus, and it also has all of the properties of a rectangle. So if it is a square, it has to have 4 congruent sides. Top has to be congruent to bottom, left has to be congruent to right, and it has to have 4 90-degree angles. Okay, so for example 1. Okay, for any rhombus RSTV, decide whether the statement is always or sometimes true. So it says draw a sketch and explain. Okay, so if we draw a picture, we have a rhombus. We know a rhombus is going to be RSTV, and if it is a rhombus, we know that it has 4 congruent sides. Okay, at that point, if it's a rhombus, we know it's a parallelogram, but we know it's a parallelogram that has 4 congruent sides. Okay, if it's a parallelogram that has 4 congruent sides, that's what makes it a rhombus. However, if it's a parallelogram, if you go back to the other day when we talked about just properties of parallelograms, we know that opposite angles on a parallelogram are always congruent. So if we look at S and V, they are opposite angles. So S has to be congruent to V every single time. So this is going to be an always because opposite angles are congruent in a parallelogram. Okay, if we take a look at our next picture, decide whether it is always or sometimes true. Now we're looking at angles. Okay, so again, if we redraw our picture, R, S, T, and V. At this moment, we know it's a rhombus, so we know it has 4 congruent sides. And again, we know if it's a rhombus, we know it's a parallelogram, and we know it has opposite angles congruent, but we do not know it has congruent angles side by side unless it would be 90-degree angles. Now, if it's a parallelogram and it's a rhombus, it does not have to be a square. It can be, but it could be a rhombus and not a square. So in that case, if it's only a rhombus, it's not going to have 4 right angles. And if it was going to be a square, it would have the 4 right angles. So this would be a sometimes, because if it's a square, it would certainly have angle T and angle V congruent because they would be 90-degree angles. However, this is not going to happen every time because at the moment we really only know that it's a rhombus. So this is going to be a sometimes. Those angles will only be congruent if the rhombus is a square, and at this point we do not know that it's a square. Okay, for any square CDEF, is it always or sometimes true that CD and DE are congruent. Okay, so if we draw our square, C, D, E, and F, we know if it's a square it has 4 congruent sides. We know if it's a square it has 4 congruent angles. So if it's a square, remember from what we've written up above, we know it's a rhombus and we know it's a rectangle. Okay, if it's a rhombus, we know it has 4 congruent sides. If it's a rectangle, we know we have 4 right angles. Okay, so if we look at CD and DE, those are side by side. That means we have congruent sides, and they're always going to be congruent. So this is going to be an always based on our properties of rhombuses and rectangles and squares. Okay, let's move it up. Focus again. Okay, example 2, classify the special quadrilateral and explain your reasoning. Okay, if we look here, we have 4 congruent sides. We know that if it has 4 congruent sides, it can be, and it's a quadrilateral, we know that it is a rhombus. Okay, we do not have 4 congruent angles, so not 4 congruent angles. So it cannot be a rectangle. And it cannot therefore be a square because it does not have the right angles, so it is just a rhombus. So if the only thing we know is it has 4 congruent sides and we know it does not have right angles, we can only classify it as a rhombus. Okay, if we take a look at part B, a quadrilateral has 4 congruent sides and 4 congruent angles. Okay, if we have 4 congruent sides, we know we have a rhombus. If we have 4 congruent angles, we know we have a rectangle. And if it's both a rectangle and a rhombus, we know it has to be a square. So if it has all the properties of a rhombus and a rectangle, that means it has to be a square. Okay, on to page 2. Okay, we have theorem 8.11, and again, I don't care that you memorize the numbers, I just want you to understand the concept. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So remember, the diagonals are the parts that connect the opposite angles. So from A to C is a diagonal, from B to D is a diagonal, and where they meet on a rhombus, it makes 4 right angles, so they are perpendicular. So ABCD is a rhombus if and only if AC is perpendicular. Remember, upside down T means perpendicular to BD. Okay, theorem 8.12, a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So again, this is one diagonal, this is the other one. It's a rhombus if AC comes up here into angle A and cuts it into equal parts, comes down to angle C and cuts it into equal parts. So the first thing we can fill in is AC bisects both angle BCD and BAD, and BD bisects going the other way again. This cuts this piece, this angle D, into 2 equal parts and angle B into 2 equal parts. So BD bisects angle ABC and angle ADC. So please just remember that the diagonals come into the corners and cut them into equal sections on a rhombus. So the diagonals bisect the opposite angles. Okay, if we do 8.13, a parallelogram is a rectangle if and only if its diagonals are congruent. So when it was a parallelogram, we had this piece congruent to that piece and this piece congruent to that piece, but not necessarily all 4 pieces being congruent. So if all 4 of these pieces are the same measure, you know you have a rectangle. So ABCD is a rectangle if and only if AC, again, is one diagonal, has to be congruent to BD going the other way. Okay, example 3, sketch rhombus. List everything you know about it. Okay, again, a rhombus. So we have F, G, H, and J. Okay, by definition, we know it has to be a parallelogram. That's kind of our beginning piece. It goes from a quadrilateral, and as soon as we know it has parallel sides, we know it is a parallelogram. We also know on a rhombus that the sides are congruent, so this figure has to have 4 congruent sides. We can go back and use all the parallelogram properties, so we know that opposite sides are both parallel and congruent. We did that with our parallelograms. We know opposite angles are congruent, and we know consecutive angles are supplementary, or 2 angles in a row as you walk around equal 180. Diagonals bisect, so this is all under our properties of parallelograms. So by the theorem that we did above, if it's a rhombus, the diagonals have now become perpendicular, so that's a little different from the parallelogram, and the diagonals bisect the pair of opposite angles, and so again that's a little different than what a parallelogram does. Okay, last example. You're building a frame for a painting. The measures of the frame are shown below. We have a 20 on top and bottom and a 16 left and right. It says the frame must be a rectangle. Can we assume that it is? Okay, let's look and see what we know. We know that the opposite sides are congruent. Okay, so we know opposite sides are congruent. Okay, if the opposite sides are congruent, that just tells us it's a parallelogram. If we wanted it to be a rectangle, we would have to know something about the angles, and at this point we do not know anything about the angles. We cannot assume that there is right angles there. So since we do not know about any right angles, the only thing that we can assume is that it's a parallelogram. We cannot assume that it's a rectangle yet. Okay, so if you measure the diagonals of the frame, and the diagonals are 25.6 inches. Okay, that's telling you that from one corner to the other and one corner to the other, they're congruent. So we have diagonals are congruent. Okay, that means it has to be a rectangle, because remember the property of a rectangle says diagonals are congruent. So that proves that it's a rectangle. Okay, that's all for your 8.4 section. So end of video.